Hello everyone, this is Eric from BLT, and today we are back to discuss the remainder of the build steps within the Vivado design suite. Previously we discussed the synthesis process, and today we'll be discussing the implementation process. So to recap the previous video, we created a simple VHDL module which infers some basic logic gates, an AND gate, an OR gate, along with an adder and a multiplier. We specifically specify that we wanted this multiplier to be inferred as a DSP block so we can see how the tool handles creating those blocks. So if we take a look at the synthesized design, we see that the tool has gone ahead and transformed our logic within our VHDL and our various other design sources, only being VHDL in this case. But if you had IPs and so on and so forth, it would take those as inputs as well and transform each of those design sources into specific silicon primitives which exist inside of the device that we have selected. If you'd like to see the device that you have selected, you can click the Project Summary tab. If you have closed this tab, you can simply click Window, Project Summary, and that will bring this up. And here we can see that we've selected a XCKU035 or a Kintex Ultrascale device. Now we see that Vivado has gone ahead and taken our simple VHDL file here and transformed those into gates which exist in the device. So some lookup tables, some carry logic, some FDREs, which are just basic D-type flip-flops, the DSP slice that we told it to infer for our multiplication, along with some input and output buffers that are needed. If we progress in the build stages, we get through implementation. Now to save a little bit of time, I've already gone through the implementation process, so I'll just open up the already implemented design. In doing so, I'll close the synthesized design. What implementation is going to do is it's going to take that synthesized design that we just looked at, that net list, and it's going to take those and it's going to map each of those primitives to a specific silicon resource within the FPGA. So if we zoom in on our device view, this is the actual image of our FPGA. This is what it looks like and how the resources are actually organized on the physical silicon. We'll see that it's gone ahead and allocated various pieces of the silicon to take care of implementing our logic. So for example, if we scroll in just a bit more here, we'll see a DSP48 slice is being used to implement our multiplication. We have a few I/O getting used here for our various input and output signals. We have some logic taking care of our adding function. And if we scroll up further, we'll also see that we have our OR and our AND getting taken care of in lookup tables. So that concludes this video. If you enjoyed this video and like to see more, please check out our channel or check us out at bltinc.com.